Welcome to the third lesson in this beginner course. In the previous lesson we made our first application. This was a text-based application used to learn about variables, functions, and UI elements. Even though it was educational, you probably really want to make a visual game. This is why today we'll learn about how to move a 3D object in Unity. There are several ways to move a 3D game object in Unity. In this lesson we will be introduced to some of these methods. You now know how to start a new 3D project via the Unity Hub. That's why we'll start this lesson right away with the Unity editor in front of us. If you need help starting a new Unity 3D project, I would recommend that you review Lesson 1 or Lesson 2 of this series. Because we want to learn how to make a 3D game object move, we need a 3D game object, so let's add a sphere in the scene view. Right-click in the hierarchy and select 3D object and then sphere. The easiest way to move a 3D object is by changing the object's transform position in the inspector window. You can change the X, Y, or Z value. This will move the object along the corresponding axis. You can change the value in the text field of the inspector. But you can also change the value by placing the mouse above the value you want to change, until the cursor changes to 2 arrows. Now you can left-click and hold while you move your cursor left or right. Another way to change the value of the transform position X, Y, or Z value is directly in the scene view. You can select the colored arrows of the game object in the scene view and drag the object along the selected axis. If you can't see the colored arrows, first make sure you've selected the game object, and second make sure the move tool is selected in the scene view. If you move a game object by changing the object's transform position X, Y, or Z value, its new position is static. For objects that don't have any interaction in your game, this is a useful way. But if you want the game object to move as a reaction on an event that's changed in your game, you have to control the movement with a script. To show how to move a game object with a script, we first have to add a script to the game object. Let's name the script movement. And let's change the position of the sphere to the origin. Set the X, Y, and Z value of the position to 0, and open the movement script. Lucky for us, we can reach the object's transform position in the script. We can give the game object to which the script is attached a new position. In the start method add transform.position equals new vector 3. Between parentheses we can give the object the new X, Y, and Z value. The result is that the game object is placed at the X, Y, and Z value we have given it. If we run the script, we'll see the value appear in the inspector. Instead of moving a game object to a specific location in the world space, using transform.position equals new vector 3, you can also move a game object a certain distance from its current location. We do this by adding a vector 3 value to the current position. Transform.position plus equals new vector 3. Between parentheses the X, Y, or Z value you want the object to move on the X, Y, or Z axis. The plus equals maybe need some explaining. In lesson 2 I've shown how you could add 1 to a number of people variable, using the statement number of people equals number of people plus 1. Adding a value to a variable is such a common thing. There's a short way to do this with a plus equals. That's why number of people equals number of people plus 1 is the same as number of people plus equals 1. If we save the script and enter play mode, we should see the sphere move to a position with a y value of 10. But if we really want to see the sphere move to a position by 10 units on the y-axis from its current position, we should start from a different position than the origin. Let's set the position on the y-axis to 1, and then enter play mode again. The y position should now be 11. So far we have replaced an object by giving it a new location in world space. This replacement takes place within one frame. But if we want to make an object move, we have to slowly change its position frame by frame. If you want to move an object by a set amount relative to its current position every frame, you can use transform.Translate. Until now we have used the start method to run code. If you want something to happen in Unity that does not happen once but every frame, then you have to use the update method. Adding the statement transform.Translate to the update method, we'll call the statement every frame by giving it x and y value of 0 and a z value of 2. The results is we're moving the game object 2 units on the z-axis every frame. If we run this script in the Unity editor, we'll see the sphere take off and fly out in the world. The only way to stop the sphere from moving is exiting play mode. There is only one problem with this approach. It looks like a smooth ride for the sphere, but the movement is depending on the frame rate of the game. The frame rate may vary between devices. As a result, the time it takes for the sphere to move 2 units every frame will be different. If we want to make the sphere move independent of the frame rate, we can scale the movement by time. This works by multiplying the transform.Translate value with another value called delta time. Delta time is a value that's constantly updated. That measures how long the previous frame took to process. Now the sphere's movement isn't dependent of the frame rate, but it would be nice if we could add a speed variable to control the speed of the movement. Let's add a public speed variable. We'll make the variable of data type float. A float is a data type that can hold a decimal value. Since we declare a float speed variable, after the value, we place the symbol f. Now we can multiply our transform value with the public speed variable. Change the z value to 1, or else the value of the speed gets twice as high. The x and y value of 0 and a z value of 1 for this situations is so common it has its own way of declaring it. You can type vector 3.forward. When we enter play mode, we can still see the sphere take off. And now we can change the speed by changing the speed variable. Normally, you don't want to just shoot a game object into the world if it is your player. You want to be able to control your player with the arrow keys, or the W key for forward, the F for left, the D for right, and DS for back. We need a way to change the X and Z values of the gameobjects transform. We do not use the Y value in our case. You use the Y to move a game object up. The first thing we need is a float variable for the X value and one for the Z value. We can use the X and Z variables to adjust the values in the transform of the game object with a vector 3. For this, we create a new variable of the data type vector 3. We call this variable movement. We give the variable the values of x and z. We set the y to 0. And we can then apply this variable movement in our transform at the location of the vector 3.forward. Before we test this in play mode, let's first turn the speed down so we can see what's happening. The sphere moves at a speed of 10 in a diagonal line. But we still can't control the sphere. What we need is a way to record user input. We then have to link this input to the x and z variables. Lucky for us, we can do just that. Just replace the value 1, replace with input.GetAxis, between parentheses and quotations horizontal for the x variable. And vertical for the z variable. This way, the user input is added to the corresponding float variable. We already made a vector 3 movement variable that's used in the transform of the gameobject. Now we can control the movement of the sphere. You can control the sphere with the arrow keys, or the W key for forward, the A for left, the D for right, and DS for back. If you are interested in why this input method works, you can look in the Input Manager. Here you can see which input axis corresponds to which keys. Please like and subscribe, so you'll get notified if a new video is uploaded. More people will get this video in their search result when they want to learn Unity game development. Thanks for watching. In the next lesson we'll continue with moving a game object, but a totally different approach. We'll start using the Unity physics system. See you there.